Okay, so that should be pretty much everyone. So we'll get started now. If anyone else is joining, they can join in a minute. Okay, so welcome everyone. For those of you, some of you know me, some of you don't, but my name is Louis and I'm one member of the QLD project team. A little bit about me, I have a keen interest in sport, music and academics, and I am a 2024 graduate from All Saints Anglican School on the Gold Coast. I finished with an ATAR of 99.85 and was a QCAA Distinguished Academic Achiever, which places me in the top 35 students in the state. And on top of that, I finished with a score of 100 out of 100 in methods. So as you're all aware, today we're here to take a deep dive into methods, but that's not actually where I want to start. So you're all entering year 12, it's definitely the biggest year of your schooling life, but for me, I definitely think it can be your most enjoyable as well. It's easy to put your head down and just grind out the study and miss the bigger picture. But so before the term starts, I think this is the perfect opportunity for you to all take a breath, zoom out, and we'll have a look at the massive year that is ahead of you. And I think the fact that you're all here giving up your time does show that you care, and that is the most important thing. Okay. So you have every reason to care. And I think the average year 12 student spends probably around 150 days at school this year. That's not a lot, and there will be many points this year where you will wish you could have more time back. It's a year full of unique opportunities and challenges that you'll only experience once, and it's definitely daunting at times, but it's also a lot of fun. I have been there, and I can tell you that everyone gets through year 12. There are thousands of students across Queensland who will be in your shoes, so you're not alone. And the best advice that I can give you is just prioritize yourself. I don't think there's anything that can be gained from just pushing through study and burning yourself out. So take breaks, do what you enjoy, and I firmly believe that that will benefit your study in the long run. Just checking, can everyone see me changing slides as well? Can everyone just raise your hand in the Teams meeting if you can see the changing slides? All right, perfect. Okay, so one reason why I think methods deserves attention at this point of the year is because if you look back on your previous term, for most of you, I know the All Saints kids, and I think the Terrace kids as well, your focus would have been on your assignment rather than the content. And that's definitely not the wrong approach. I was the same. You want to work as hard as you can on your assignment. But that does mean that there may be more gaps in your knowledge than you realize when it comes to content. So that might not seem like a massive issue to you right now because there is still a lot of time before your exam. But in contrast with your other years at school, assessment in year 12 isn't linear, and you'll have assignments that compound on top of each other, that overlap with exams, and before you know it, you could be too far behind to catch up. So what I'm aiming to do with this masterclass is to cover content you should have already done to help you all keep on top of it. And as you'll see shortly with the syllabus, many of the concepts do tie into each other. So consolidating is a good idea, and try to avoid playing catch up if you can. I think most of you should have already done your 20% PSMT. So you have banked 20% of your year grade. And then still to come is you have two 15% internal exams and your external, which is 50%. So, and because of that, a common misconception is that your internal exams aren't as impactful, but trust me, having a school written paper is a luxury that you don't want to pass up. Your teachers are going to try and help you as much as they can, and in writing the exam, they will be able to prepare you really well for getting a 15 out of 15. And then regarding the EA, it's definitely a lot less predictable than the IAs. So bank those marks while you can to save you having to gamble on pulling through in the external. And what I personally found is that good focus study on your IAs actually does really help you prepare well for the EA as well. And so unlike other subjects where you have large assignments that are largely unrelated to the content, your methods internals do theoretically reflect what you see in the final exam. So use that use those study habits to your advantage so that when the external does roll around, you will be going in with as much knowledge and confidence as possible. So having a roadmap for study is important. If you know where you're headed, studying does become simpler, more efficient, and more effective. So in my mind, the best tool for gaining clarity about where you've been, where you're going, and where you are right now is actually to use the QCAA syllabus. So the syllabus is often an overlooked document that students don't really use, and I found that teachers don't really use when they teach either. But when you use it strategically, it can help you know exactly what concepts to target, to gauge how important different topics are and how heavily they're weighted, and how they link to other topics, and see where areas overlap and connect. So first of all, I'll show you your syllabus at face value. So this is topic 3, which is integrals and applications and just integration for methods specifically, and it's a major part of methods. And this is roughly where you should be up to right now. And differentiation links to integration, and it's a massive topic, probably the biggest in methods. And so according to the syllabus, you should have gone over this in class, and we'll test your knowledge in a second, but I want you to pay attention to the little indicator of the expected hours next to each subtopic. So this is where I think you can take a bit of a strategic approach. So for example, you can see calculus of exponential functions. You should spend about 8 hours of class time on that. And in relation to differentiator and rules, 5 hours, etc. with the other topics. So the allocation of these hours should align roughly with the weighting of each topic in your exam and how likely you are to see a question from those topics. So for example, you might expect the 8-hour subtopics here to be twice as prevalent as on the exam as something that only has 4 hours dedicated to it. So with this information, you can more efficiently and effectively target certain areas of your study. And so this is topic 1, which is also a further extension of differentiation, just to show you how massive the calculus topic is in methods. The focus of this masterclass revolves around differentiation and integration, which are the fundamentals of calculus. I've just shown you the syllabus sections that you've worked through in class, but if you look at some topics that you haven't covered yet, there's actually still quite a significant amount of calculus left to go through. Calculus, as I said before, is by far the biggest topic in methods and is something that you will use throughout both Unit 3 and Unit 4. So now that we've covered that, we can move on to some more practice questions. So this is question 1 of this masterclass. So how this will work is as follows. I've chosen 5 different questions split between differentiation and integration, and they're all taken from previous external exams for 2 reasons. So firstly, so it will accurately represent the type of exam style questions you could be asked, and typically your IAs will try and mirror the wording that you'll see in the external as well. And also the external exam database is public, so you can revisit these questions just by searching up QCAA 2021 methods external if you'd like after the session. So I've specified as well whether a question is tech active or tech free, and I've given you an allocation of the time frame that I'll give you to solve it. So for this question, I'll give you a 6-minute timer, and if you want to have a go at this question, you can start now. Okay, so you have about 1 minute left for that question. Okay, so that's 6 minutes up, and for a question like that worth about 4 marks in an external with 3 parts, that's generally the amount of time you should look to spend on it. And similarly, if you're given a question like that in your IAs, I reckon 6 minutes is a good amount of time. The way we sort of weight it is you want to spend about 1.5 minutes per mark across your exam, and that should allow you to finish with enough time to go back and check. That's the general practice for exams. So what I'll do now is I'll stop sharing my screen there, and I will share my OneNote with you, and I'll show you how I would tackle this question. If you have any questions, just unmute yourself and let me know, or type it in the chat and I can answer them for you. Okay, so when you're given a question like this regarding deriving natural logs, the first thing I like to do is just look at what's inside the bracket here. Can everyone see my screen as well, just quickly? Just raise your hand if you can see it. Great. Thank you. Okay, so what you want to do first is just assign an arbitrary letter or pronumeral to what's inside the bracket, and I'll just use U for this. So when we're deriving natural logs, what's in the brackets is key. So then find the derivative of U, which is just 3. So what I then do is, when you're looking at the derivative of the entire function, for natural logs, the general process is U dash over U. So in this case, your derivative is just going to be 3 over 3x plus 4. Are there any questions so far about that? Okay, perfect. So then that leads me onto the second part of the question. Similar to what you would have covered in year 11 and even year 10 when you're looking at graphing functions. And essentially you just need to apply the same process. So you all know that at the x-intercept, y equals 0. So what you do is you just substitute 0 equals ln 3x plus 4. And then using your log laws, you know that ln is equal to log base e. So you can move this over here. And so you know that e to the power of 0 equals 3x plus 4. From there, anything to the power of 0 is just equal to 1. So if 1 equals 3x plus 4. From there, you should be able to just solve algebraically to get 3x equals negative 3, x equals negative 1. So that will be your x-intercept. And then part C is just, it's a very common exam style question where you have to solve the first 2 parts to find the answer to part C. And so it's just straightforward, substitute your x value at the x-intercept into your derivative equation. So you just go f dash yx equals negative 1. Substitute that in. 3 over 3 times -1 plus 4. Which gets you 3 over 1, which is 3. Okay. Did anyone get the same answer as me? Just raise your hand or give a thumbs up if that's what you got. Perfect. Okay. Seems like you're all across that. Does anyone have any questions before we move on to the next question? You can type it in the chat or you can unmute yourself. Okay, we'll move on to the next question then. Okay, so have a go at this one as well. This one's also from the 2021 external. And this one covers more differentiation using chain rule and quotient rule. So have a go at this, and I'll give you 8 minutes, and you can start now. Okay, you've got about a minute left for that question, but if you're all done, if you're done, just raise your hand and I can show you the answer if everyone's finished. Looks like, yeah, looks like most of you are done. So I will share my OneNote and I can show you the answer. Okay, so with respect to part A, you should have identified that this involves using what we call the chain rule in methods, which is something you would have, I think you would have covered in year 11 as well. But just to refresh, if you have a look at the formula book, it says if y equals fu and u equals gx, then we can apply this rule. But essentially all that's saying is that if your function here involves another function in the brackets to the power, then we use the chain rule. So the first step here is to look at what's inside the brackets. So you go u equals e to the x plus 1. Then you find the derivative, which is u dash, and that is just e to the x. Because the derivative e to the x is e to the x, and the derivative of 1 is 0. So in that case, you can then generally just differentiate in the same way you normally would. Y dash equals 3 e to the x plus 1 power of 2. But the key thing with the chain rule is you have to add chain on the derivative of u. That's the key thing. So that just works out to be 3 e to the x and then e to the x plus 1 all squared. Pretty straightforward, and that should be part A. With regard to part B, this you should have identified this involves using the quotient rule. And so if we look at it as y equals u over v, we can identify that u equals sine x and v equals x squared. So then we find the derivative of both of those. You have u dash equals cos x and v dash equals 2x. Are there any issues with what I've got so far? Any questions? Okay, there's no problems. Then we get to the quotient rule. So if you refer to your formula book, you can see that using the quotient rule, the derivative of y is just going to be v u dash minus u v dash all over v squared. We have all our values just here, or all our expressions, sorry, and so we can just put that into the formula. So x squared cos x minus 2x sine x all over x squared, all squared, which is just x to the 4. So this here is your first expression for the derivative, but if you refer back to the question, it does ask you to give it in simplest form. And so what's key to look at there is just if you can take out any common factors. And so I can see that both terms on the numerator have an x in common. So I can take that out the front. And once you see that, you can then cancel with the denominator, and that leaves you x cos x minus 2 sine x all over x cubed. And that should be your final answer in simplest form. So raise your hand if you had the same answers to part A and part B as me, or if you have any questions, put it in the chat or just unmute yourself. looks like a few of you got the same. Were there any questions at all? Or? Okay, if you're all happy for me to move on to the next question, just raise your hand and we'll move on. Okay. Also, if you find the time limit is too long, then if you find the time limit's too long and you finish early, just raise your hand when you're done, and if enough people have finished, I will move on to my answer. Okay, so that covers the topic for differentiation. That covers a couple of questions, and so we'll move on to a bit of integration. So this is a pretty straightforward, very simple multi-choice using definite integrals. So it should take you 2 minutes. Just have a go at this, and then we'll quickly cover the answer. Okay, that should be your 2 minutes basically done. So raise your hand if you're finished, and I'll move on and show you my answer. Okay. So first of all, I'll show you how to do this question by hand. And then, but it is important to note, if you had a look on the PowerPoint, it said that the question is tech active, so you can actually do this on your calculator, which I'll show you in a minute. So with your multi-choice questions, it's good to get really fast at doing them, but especially for the external, it comes in really handy if you can fly through those. But if you've covered definite integrals, this should be really, really basic. So first of all, you just want to integrate what you have here in the brackets. So that just comes to x squared. The integral of 2x is x squared, and the integral of 3 is just 3x. No need for your plus c's when you're doing definite integrals, because they don't actually make a difference. So once you've got to this stage, all you have to do is substitute in the 3. So you get 3 squared plus 3 times 3 minus, and then you substitute in the 1. 1 plus 3 times 1. That gets you 9 plus 9 minus 1 plus 3. which is just 18 minus 4, just comes to 14. So your answer there should be C. Did anyone get the same answer as me? Okay, great. Are there any questions so far? What I will actually show you as well is I know All Saints students should use the same calculator that I do, but I don't know about Terrace kids what calculator you guys use. But just quickly with this question, you can do this really quickly using the calculator. So if you just go into the menu, this is for TI and Spire calculators, and you go to calculus, you can solve a numerical integral. I don't know how well you can see that, but it comes up, and then if you just plug in the values, which is your bounds are 1 and 3, and then 2x plus 3 different integrate with respect to x, and it spits out the answer immediately. So that saves a little bit of time in multi-choice questions, especially in Tech Active. Okay, if there's not any more questions, I'll move on to the next question. So this one's another multi-choice question. This one's tech-free from the 2020 external. So it should only take you another 2 minutes. Just have a go at that, and I'll take you through it in the next 2 minutes. If you have any questions, just message the chat or unmute yourself. Okay, that should be roughly 2 minutes done. So raise your hand if you finished, or I can give you another minute. Okay, perfect. I'll take you through my answer now then. Okay, so this one is, I find these general integration questions slightly more difficult than definite integrals sometimes, but overall, these aren't actually too bad. So if you can try and get fast doing integration, that will really help you for your external. So first of all, let's write out what I'm integrating. So the first thing I'll do is I'll just leave the 2 outside. We can leave the 2 outside the brackets. Then what you want to do is you want to look at what's in your actual integral and what's in the brackets, what's being cubed. So you have 4x plus 6 all cubed. So if you think about it like a basic integration, you want to raise the power by 1 and divide by the new power. So you have 1 over 4, 4x plus 6 to the power of 4. But it's also key to remember that when you're deriving this here, you'll actually have to multiply it by the derivative of what's in the middle as well, which is just 4. So when you're integrating, you want to divide by it. So I need to add another 1 over 4 there. And then you have your constant of integration as well, plus c. So when I'm solving that out, you have 2 times 1 over 16, 4x plus 6, 4 plus c, which should all simplify out to the 1 over 8, 4x plus 6 to the power of 4 plus c. And if you have a look at your options there, you can see that this matches up with option D. So that should be a final answer. Were there any questions, or just raise your hand if you got the same answer as I did? If you have any questions, just type them in the chat or unmute yourself. But if you're okay to move on to the next question, just raise your hand and we'll move on. Okay, if you're all happy with that, then we'll move on to the next question. So this here is your final question for today, for this masterclass. This one is a bit longer, 3 parts. Generally will take a bit longer and it's a bit more in depth. We've got a bit of time left, so I'll let you run through that. You can start whenever and just raise your hand when you're finished and I'll take you through my answers. Okay, so we didn't spend overly long on that question, and if you haven't finished, that's okay. But if you have, raise your hand, and even if you haven't, we haven't got a whole lot of time left, so I'll take you through the solutions. This question is definitely more challenging. It's more towards the lines of the complex familiar or complex unfamiliar. But the wording is, the question itself isn't that difficult once you decipher the wording. So I'll take you through what I have. Okay. So the key thing here is that you're given the rate of change in population for the two cities. And so part A is asking you to find the population models. And so when it says model, it's just asking you to find a function for each population. So we start with A. The process is just to integrate the given function with respect to t. And so what you can do is you can take this 45 out the front, left with 1 over t plus 1 dt. And you know that 1 up here is the derivative of t itself. So you know that this should just work out to be ln t plus 1 plus c. The key thing here, though, is that this isn't actually an accurate model for the population because you still have a constant of integration there. So if you read the question, T is the number of years since 2018, and both A-T and B-T are measured in people per year. So at the beginning of 2018, City A has a population of 5,000 and City B has a population of 3,500. So you know when T equals 0, A should equal 5,000. So 5,000 equals 45 ln 1 plus c. And ln 1 is just 0, so c should just equal 5,000. So therefore, your population model for AT should just be 45 ln t plus 1 plus 5,000. The process for finding the population model for B should be the exact same thing. Should just be the integral of 105 e to the 0.03 t dt. So to find the general form, you want to divide 105 by 0.3. And you can use your calculator. This is tech active. So that just comes to 3,500 e to the 0.03 t plus c. Now, you know that during 2018, the population of City B is 3,500. So you can substitute this in and find 3,500 equals 3,500 e to the power of 0 plus c. E to the power of 0 is just 1, and 3,500 minus 3,500 is 0, so c equals 0. Therefore, bt equals 3,500 e to the 0.03 t. So that's part A. Did anyone get the same as me? Just raise your hand if you're the same. Okay, so that's the big part of this question, is finding that model. The rest is using your models that you find to then find the final answer. So the part A, this is very typical of exam questions where the first part is required to solve for the remaining parts. So part B, use the information in 12A to predict the population of City B at the beginning of 2028. So you know that 2028 is 10 years after 2018, so you can just substitute T equals 10. which is 3,500 e to the 0.03 times 10, which equals 4724.51. Now, it's important to note that this is in people and you can't have half a person, so you always have to round down. 4724. And then part C. So use the information in 12A to predict the year in which the population of both cities will be the same. So this one is a very calculator specific question. You couldn't really do this if it was tech free unless there were nicer functions. So when the population is the same, you just want to go when A equals B. So you put those, if you equate these, then you have an equation with only one pronumeral in it. And what you can do in this respect is if you have a calculator that supports it, like the TI Inspires or the graphics calculators you should have, you can go into the numerical solve function and solve for a value. Put this into your calculator and it should spit out a value that is t equals 12.66. If you have issues getting to this stage, that's okay. Just ask your teacher to take you through how to use your specific calculator. So then once you've got this number, you know that when t equals 0, the year is 2018. So you just go 2018 plus 12.66, just get you into the year 2030. Therefore, in the year 2030, during that year, the populations will be equal. That question was a bit more full on, but did anyone get the same answers that I did? Okay, that's good. If you're struggling with that, that's no problem at the moment. It's no stress. You can talk to your teachers about some more difficult questions and how to approach those. But the key thing with them really is looking at the wording and just practicing them. That's the best way to do it. And with these big mark questions, there's a lot more to it. If you want to take a screenshot of my working or anything, feel free, but you can also find this question online if you search up the 2020 external. Okay, so that was it for the questions that I had. So just takeaways from this presentation. So if any of you felt you were pushed for time, as I said before, we theoretically try and allocate 1.5 minutes per mark in order to finish in time. That's on balance. Like you'll spend more time on complex unfamiliars and hopefully less time even on the simple familiars, especially the multi-choice. That's why I'd recommend doing some form of time study when you practice or time practice with your externals. Don't have to do it all the time, but definitely in the lead up to your exams, I think would definitely be a good suggestion and gives you an idea of how well you are equipped to attack each topic. If you do all of that, if you do the revision questions your school sets, then you'll be really well placed for your IAs. And if you practice past papers, you'll be really well prepared for the EA. So if there's any final questions, feel free to just put them in the chat or unmute yourself. But otherwise, we're pretty much finished. If you struggled with the questions, that is okay, by the way. Like those were generally all simple familiar, but like the last one, there were definitely additional layers of depth to them, especially if you haven't revised them for a while. If you can lay down those foundational rules for each topic, then you will find that methods becomes a lot easier and you'll be able to understand your complex familiars and unfamiliars much more easily. If you did find those questions easy and you could do all of them, that's great. I've got some more extension questions for you here that we won't cover now, but you can take a screenshot of and you can have a go in your own time. I'll also post on the Acuity Project website some videos where I work through these questions myself. If you haven't covered the content required for some of these questions, that's okay. You will cover it this term, and don't feel any pressure to if you can't actually solve them, because you might not have the appropriate knowledge yet that you haven't covered in class. So feel free to take a screenshot of those now, and if you're all ready, I'll move on to the final slide. So finally, I just want to show you some resources that you'll find useful this year. So this masterclass that I'm running is under the Acuity project, and we will be looking to run more masterclasses later in the year, particularly for maths and sciences. But beyond that, Acuity has a lot that it can do to help you. There's free 24/7 support where you can submit questions onto the website, and myself or Lockie, the founder, will record a personalized video for you breaking down the question and how to answer it. It's easy and efficient, and we want to make sure that you get the support you need whenever you need it, rather than simply forgetting the concepts that you didn't quite understand and then falling behind. It's completely free, costs you nothing, so give it a try. We also offer tutoring and mentoring programs through the website that have been specifically designed for Queensland Year 12 students. So if you've been thinking about getting tutoring, it is a great opportunity. And if you can get on top of your schoolwork at this point in the year and create good study habits, then you'll be miles ahead of everyone else. Creating good habits now is what sets you up for the external, because you can generally do really well on your internals without a whole load of study, but the externals require the extra effort and the extra mile of work. You'd be working directly with myself or Lockie, and we both have very comprehensive knowledge of the QCAA syllabus, myself having graduated last year and Lockie graduated in 2022. So if nothing else, just go and have a look at the website and see what we're all about. And if you ever need us, we're always here. So enjoy the rest of your public holiday and enjoy your first week back. I hope you found this masterclass useful, and hopefully we'll see you again soon. So thank you all for your time, and you can leave whenever you're ready.